End up at? Liam, can you do the first differences for me, please?
You go 13 minus 1. I confused.
It's okay. Somebody help me. It's all right. Lexi, guys. Oh no.
15.
Really? Yeah. So what you do? Okay. Remember? Okay, please, sir. Now the reason can I talk, please? The reason this is difficult, even for me to teach you guys, and when I think about this is difficult because you're subtracting the opposite. Okay, right? Like to me, I think 13 minus 15, but it's not. Right? It's 15 minus 13 going upwards. Okay. So you're going to say the way again I think of it as is like 13 plus 2 is 15. Okay, that's the way to go. So or 15 minus 13 is 2. All right. All right, Emily, what's 19 minus 50, please? 19 minus 15. Great. 6, 8, 10. There is a lovely pattern in there, okay, an outstanding pattern, if you will. Okay, now for as far as the second differences go. Karina, how do you do the second difference?
Did you just do the same thing as the other number, so 4 minus 2?
Very good. 4 minus 2 is going to be 2. 6 minus 4 hopefully is going to be 2. 8 minus 6 is 2, and 10 minus 8 is going to be 2. Okay. Megan, now for the most difficult question of the day. If the second differences are the same, what type of equation is this going to be? I'll give you a hint, it starts with the Q. Quadratic, very good. And you'll find out in this example, I'm going to do one more example after this, and I'll be done for today. I'm going to show you how it goes. Okay, can I get some started here, and then I'll come back to you, okay? So it's going to be quadratic. So what I'd like you to do while I'm holding this right here is to get this graphed up, okay? So as far as the graph goes, this should be, there's your x, there's your y. All right, now, will this be a straight line? Definitely not. Guaranteed not to be. If it was a straight line, these would all be the same number, right? That would make it a straight line. But what it's doing here, the slope should be changing, so this will definitely not be a straight line. So get started on your graph. I'm going to hit pause, and then we'll take this one up, okay?
You don't have to do like the 4. There's no.
The question was, you don't have to do this type of graph. Why do I not do this type of graph? There's no negatives, right? So probably this type of graph. Probably this type of graph. Okay.
Did you go with that?
Yeah, that's fine.
I've joined graph paper so I can actually count by 2s and get away with it. You guys would probably have to count by 3 or 4 or 5. As well, if you want to do that little squiggly thing and start at 13, you may. Right, instead of starting at 0, it's okay to do that as well. Please remember, and I'm going to show you an example here in a sec, even though I count by 2s going up and down, you don't have to count by the same scale left and right. Maybe I can get up that high, okay? So I only have to get up to 5. So I'm going to count like 1, 2, 3, 4, 5. Okay, so do you guys see what I did there, right? Even though I counted like very, very small, going north-south, going east-west, I left big, huge spaces to use all my graph paper, okay? And again, I'm going to embarrass 8 in this time, embarrass 8 in this time, okay, right? But again, so if you have this much room going to the right, you might as well use that much room. You don't have to, it's not incorrect, okay? usually 1 squared is 1, that's still technically correct, but it's usually see like that. Okay, so we have 0 and 13. 0 and 13 goes something like this. 1 and 15 goes like this. 2 and 19 goes like this. 3 and 25 goes like this. 4 and 33 goes like this. And 5 and 43 goes way like this. Now what is that thing? That's definitely not a line. What is that? Curve. It definitely looks like a curve to me. Okay, and if we were to do the in-between points, we'd find it would be a curve. So on this, if you want to use a ruler, you can, but for the first time for quadratics, you don't have to use a ruler. Okay? You can just connect the dots with the curve as long as you're sort of neat about it. Okay. And we'll do one more of these, I think. We'll do one more of these, I think, and then I'm going to stop for today. Okay? All right, questions and fears about that? Okay, this is what this whole unit's about here. All right, so this is, I should put the title here. This should be example 1B. Okay, before I move on to letter C, are there any questions about what just happened there on number B? The second difference is sort of the new part of today. Okay, so the way we get the second difference, right, was just take whatever your first differences are and then just continue it on. Okay, and again, then you heard me joke with Mr. Kemp. He would make you do the third difference, fourth difference, fifth difference.
Yeah, what's the point of it? Like, they just didn't do anything with them.
Well, we will for this here, what the second difference is, because the idea is we don't want to have to graph. Okay, like look how long that took us.
Oh, she just made
Exactly.
well, you're
Just, okay, just this is day one. This is day one in the unit. Okay, so I'm going to show you many different things. Okay, on the first day, just to get the idea. But the logic is the second difference is the same. Means that it's an x squared. But the second difference is the same equation.
Yeah,
As
but you're okay.
right, that's what this means. The second difference is the same. There's going to be an x squared. That's all I'm saying here. Okay, and that's eventually what we're going to make equations and all that using this table. We'll eventually learn how to make an equation. 1, 2, 3. Go ahead.
What does the x squared, or what's the second difference mean for the graph?
It means that it's going to be going upwards because the second differences mean that this is going to be twice as big as a regular x squared graph. Okay, we'll deal with that. We'll deal with transformations and stretches and stuff like this eventually. So it's going to be based on that'll help us to tell stretches. That's basically what it is, right? So like this is how the regular x squared graph looks. We'll deal with that. Someone you
Oh,
will.
I didn't.
Yeah, go ahead.
So, if the first difference is the same, then it's linear.
Yes.
And if the second difference is the same, then it's
Quadratic, or like it has an x squared. Quadratic, remember there's an x squared. So an x squared graph will be a curve like this. And I'll do one more x squared graph and then I'll stop for the day. Okay, here we go. Here's example C. Hopefully the computer doesn't die on me here again. Okay, so there's your graph. I'm going to hit pause in the video and try this one out, and then